Okay, in this section we'll look at the types of data that we'll be dealing with in this particular course. Okay, here the subject of statistics is largely about using sample data to make inferences about an entire population. It is essential to know and understand the definitions that follow. Okay, so here we have some definitions that we're going to have to be dealing with in this particular course. One of them is parameter. A parameter is this. It is a numerical measurement describing some characteristic about a population. And here you can see population and parameter, those two go together. They both start with the letter P. If that helps you to remember, population, you're dealing with the parameter. And then the other one is a statistic. It is a numerical measurement describing some characteristic about a sample. So in this case here, we have sample and statistic. Those two go together. They start with the letter S, so that can help you remember that statistic deals with a sample, and then a parameter deals with a population. In fact, let's look at some examples of situations where we can determine whether a value is a statistic or a parameter. Okay, now how do a parameter and a statistic differ? Already I just got through talking about that. Pretty much a parameter is a numerical measurement of a population. So here we can say a parameter is a numerical measurement about a population. Okay. Whereas a statistic, it is a numerical measurement about a sample. A statistic is a numerical measurement about a sample. Okay. That's the difference between those two terms. And be familiar with those two terms, because in this case here, the next examples that I will present to you will have you identify which one is a parameter and which one is a statistic. So in this example, we want to determine whether a given value is a statistic or a parameter. Okay. So in this example E2, a study was conducted of all 1,015 workers in a certain state. Now the key word that you're looking at is the word all. Okay, we're dealing with all 1,015 workers in that certain state, so that means this must be a parameter. Okay, because it is a numerical measurement about a population, and the word all tells us that that particular number relates to a population. So here, that numerical measurement is a parameter. Example E3. In a study of all 3,734 seniors at a college, it is found that 55% own a television. Again, the key word here is all 3,734 seniors at a particular college. So that tells me that particular numerical measurement is a parameter. In example E4, a particular country has 40 total states. A particular country has 40 total states. If the area of all 40 states are added and the sum is divided by 40, the result is 192,758 square kilometers. Determine whether this result is a statistic or a parameter. Again, we're looking at the area of all 40 states. They're added up and divided by 40 to get that number. So here, that number represents a numerical measurement of a population parameter. Okay. Now I realized in this video I gave examples that were all parameters and not one that dealt with a statistic. Okay. But I can make one up that deals with a statistic. Anytime you see something like this, let's say a sample of 3,734 seniors at particular colleges revealed that 55% own a television. If it says something like a sample, then that will be a statistic. Okay? So in a sample of 3,734 seniors or college seniors, 55% own a television. That statement would be a statistic, because 3734 will be a numerical measurement about a sample. So it's a statistic. Okay, now let's look at some more definitions. Quantitative or numerical data. Quantitative data consists of numbers representing counts or measurements. Quantitative data represents counts or measurements. Like the weights of supermodels. That's quantitative data. Or the age of respondents. That's also quantitative data, because those are numerical data values that represent counts or measurements. And then the other type is a qualitative data, or sometimes it's called categorical data. Those consist of names or labels that represent categories, like, for example, gender of professional athletes, male or female. That's considered to be categorical data. Another example, shirt numbers on professional athletes' uniforms. Those are substitutes for names, but that's categorical data. Okay? Because those shirt numbers represent ID numbers of that particular professional athlete. Okay? Also, your student ID number is considered to be categorical data because that identifies who you are. Also, Social Security numbers is another example of categorical data. Okay, because student ID numbers and Social Security numbers may have numbers in it because it has numbers. It's not necessarily going to be quantitative data. It's called categorical data. Okay. Now, with quantitative data, which deals with numbers or counts, quantitative data can be further described by distinguishing between discrete and continuous types. So quantitative data can be broken up into two kinds of quantitative data, discrete or continuous. So what's the difference between those two? Discrete data results when the number of possible values is either a finite number or a countable number. In other words, that means we can count certain items. That will be discrete data, like the number of eggs that a hen lays. That is discrete data because we can count the number of eggs that a hen lays. Or the number of students in a particular class would be discrete data because we can count how many students there are in a particular class. The other type of quantitative data will be continuous data. Continuous data results from infinitely many possible values that corresponds to some continuous scale that covers a range of values without gaps, interruptions, or jumps. In other words, continuous data is data that can be measured precisely, like the amount of milk that a cow produces. For example, will be 2.343115 gallons per day. We can measure that to a precise number. Any data value that can be measured to a precise number, and is usually in the form of a decimal, that would be continuous data. Now, the only exception to that would be probably money, because money would be the amount of money that you have in your pocket would be considered to be discrete data, because we can count how much money we have. Okay, let's look at a couple of examples that deal with discrete and continuous data. Like this example, determine whether the given value is from a discrete or continuous data set. In this case here, when a van is randomly selected, it is found to have 2 wipers. Okay, so here we can count the number of wipers there are on this particular van. So here, anything that can be counted is discrete. So this data value is discrete. So that came from a discrete data set. Okay, now another example is this one. When a car is randomly selected and weighed, it is found to weigh 1,700.4 kilograms. In this case, the weight is in the form of a decimal. So here that car was weighed with a precise weight. So here this is something that can be measured to a precise value. So this would be continuous. Okay. All right. Now let's look at the 4 levels of measurement. This is another way to classify data by using the levels of measurement. The lowest level of measurement will be the nominal level of measurement, and that's characterized by data that consists of names, labels, or categories only, and the data cannot be arranged in any ordering scheme, such as low to high. Like, for example, the survey responses, yes, no, undecided. That's nominal data, nominal level, because those responses cannot be put in any particular order. Or we can't come up with a scheme to put yes, no, or undecided. The second type is the ordinal level. This involves data that can be arranged in some order, but the differences between data values either cannot be determined or are meaningless, like course grades, A, B, C, D, and F. Those can be put in order, but here we can't come up with differences between an A and a D. And if we could, it would be meaningless. Okay, the third type is the interval level of measurement. This involves data that can be arranged in order, and the difference between any 2 data values is meaningful. However, you don't have a natural 0 starting point where none of the quantity is present. Like, for example, years 1000, the year 2000, the year 1776, and the year 1492. That will classify as interval level, okay? Because I can come up with the difference between 1776 and 1492. I can find out how many years those 2 are apart, However, you don't have a natural zero because 1 BC, after that it became 1 AD. There is no natural zero in the years. And then the fourth is the ratio level. In this case here, you have the additional property. It's the interval level with the additional property that there is also a natural zero starting point, where zero indicates that none of the quantity is present. For values at this level, differences and ratios are meaningful. Like in this case here, price of college textbooks could be this. $0 represents no cost. A $100 book can cost twice as much as a $50 book. Okay. So those are the 4 levels of measurement. And I have a few examples that are just like that. Here you want to determine which of the 4 levels of measurement, whether nominal, ordinal, interval, or ratio, is most appropriate. Like the position of runners in a race. Okay. Now the positions can be put in some particular order. Okay. And that's pretty much as far as we can go with that particular level. Okay. So in this case here, that's ordinal. And then example E8 is the types of movies: drama, comedy, adventure, documentary, etc. The lowest level for this one will be nominal. Now this can't be put in any particular order. Okay? I mean, it wouldn't be put in any type of set order, so it has to be nominal. And for example, E9, the brands of toothpaste, that's also nominal as well, because the brand names of toothpaste cannot be put in any ordering scheme. Okay. Okay, so that's pretty much all the examples that I have for these 4 levels of measurement. So do be familiar with those 4 levels of measurement, and here's the summary of all this. Nominal only deals with categories only. Ordinal will be categories with some particular order, like freshman, sophomore, junior, senior. There's order there, but that's as much as we can get with that. The interval, there are differences, but they don't have a natural zero point, like the years that we talked about. There was no year 0. And ratio, there are differences, and there is a natural zero point. Books can cost $0. Books can be sold for free, $0. And also, a $100 textbook is twice as much as a $50 textbook. Okay, so that will conclude this particular video on the types of data that are used in statistics.